Hi everyone, welcome to today's session. We're going to talk about building the ideal GraphQL server workflow featuring GraphQL Code Generator. So the title is a bit misleading because this is about my ideal workflow, and I'm sharing my journey, the motivation behind this workflow, the requirements my team and I set for ourselves, and the process, the planning on how to build this, and finally getting to the solution, the integration with the rest of the teams in the companies I work at. So who am I? My name is Eddy, and I'm from the Guild. I am one of the maintainers of GraphQL Code Gen by night. And by day, I'm a product engineer at a company at SIG in Australia. So I want to talk a bit about the Guild. We maintain a lot of open source tools and products, things like CodeGen, Yoga, inspectors, products like Hive Router and Gateway. So we're kind of building the foundational for the GraphQL community. Now, back to the talk. I want to do something slightly different in this talk. I want to fast forward 15 minutes into the future, and we're going to see a glimpse of the solution. Right? So everyone jump into my time machine, and this is a very simple schema. We got like a character type with ID and name, and the data is properly stored in a table, right? Like character table with these fields. And on the right-hand side, we have the character resolver map. And currently, there's no ID and name. And this is valid, right? Because when we query from the table, we return it from the parent. And we don't need to resolve ID and name, probably because they have the same type and can be forwarded to the browser or the client. Now, this is where the workflow starts. Let's say my team wants to add a new field called starships, right? And then starships probably stored in a very different table called starship table. And every character have an array of starships. So what I want to do is, as soon as I add this into my schema, there's going to be a skeleton resolver being injected into my application code, and it will ask me to implement this business logic so that we can get to implementing the important feature for our business, right? Okay, so that's what we're gonna get to by the end of it. But before we get there, I wanna tell like a story, right? So everyone, let's go to the back, to the past, and it's about a time when I joined a brand new team. This team has a GraphQL server in Node.js. Very excited, my own GraphQL server to tinker with. But upon further inspection, the first thing I noticed is there's no types, or more accurately, they're all manual typing in the server. And what that means is when the schema changes, engineers have to go in and update the types manually, and like sometimes people will forget, right? So, which leads to a lot of runtime errors in production. There was so many runtime errors and incidents that happens. And because of that, development speed, like feature turnaround, becomes a lot longer. Lots of rollbacks. So at this point, all the engineers and the team are sad, right? Product managers, even sadder, they can't get their product out of the door. So everyone is sad. And that's a picture of me. Like, this is not a meme. My hair was white, eyes bloodshot. And when I get home, my wife didn't recognize me. She said, I married a different sad man, not this particular sad man. So this is when I knew I have to do something drastic about this workflow that we currently have. So me and my team sat around and we kind of brainstorm an ideal workflow for us, right? What does it mean for our team? So we want type safety by default and TypeScript. We're already working in TypeScript environment in every other service, but not this one. So we want type safety by default. We also want runtime errors caught early, and that means we cannot deploy to production if there's any chance of runtime error happening. And we're going to talk about that in a second. And we want speed of development prioritized. So that means getting to the business logic ASAP. And that's the first thing we want our engineers to think about, not doing all the boilerplate stuff, but getting to business logic. So let's drill down into type safety. So what we want in our type safety is, in this example, this is the character resolver map, right? And when we are in this character resolver map, I want all of our resolvers to be discoverable, like auto-completable. Hopefully that's the right word in English. And then when I start writing the Starship's resolver, we can see that I'm trying to pick the ID and name from the parent. It's all type safe there, and you can pick it. And then when we're trying to return the result, every element is also type hinted. So that's the type level of type safety that we want, and everything is kind of wired into this resolver using that characters resolvers type, right? So minimum TypeScript interference, but maximum type safety for our team. Cool, we just talked about type safety by default. Now we want to talk about runtime errors caught early, right? But so let's talk about runtime safety, what it means in GraphQL. So let's extend our GraphQL schema a little bit. So now we got the character query, which returns a character type, right? And every character has an ID, it has a name, Starship's array, and like a character type being human or droid. So with this schema, then the backend team create something like on the right-hand side, right? Like a kind of like skeleton with some dummy data like this. Cool. And when we plug these resolver maps on the right-hand side into a GraphQL server in Node, right? Things like Yoga and Apollo server, can it run? The answer is yes, it can run. It can be deployed to production. However, is it runtime safe? And the answer is it depends, right? And it's fully dependent on the client. In this example on the left-hand side, we got an operation that a client can send to the server. And if there's only a query that tries to get character ID and name, it will run fine. Everyone is happy. This is deployed to production, and things keep chugging along. So that's fine. Now, everyone's happy, as I was saying, until someone tries to query for Starship array, right? And this is perfectly valid because we already published a schema that that declares that you can return an array of Starships. So this is fine, but it will have a runtime error, and an incident happen. And we need to write the Starship resolver for this to properly return an array. If not, this is just return a null, which will have runtime errors. So this is the first incident that would happen in this scenario. Now, when that happens, the backend team would frantically write something like this character Starship resolvers, right, to return an array and deploy again, and everyone is happy again, right? Like things are chugging along very nicely until someone from the client team tries to query for type. Now this again will fail because our character query resolver is returning a numeric type, but we don't have a character type to resolver to turn that into human or droid string that our schema expects, right? So this is the second failed deployment or second incident that happened really quickly. So at this time, Everyone is really sad, which means to fix this, the character type needs to be implemented. Something simple like on the screen at the moment, right? There are many ways to implement it, but this is what we need, and then things get deployed again. So, walking back to our original schema, right? When we receive the schema, it's almost like we need like a skeleton of 3 resolvers on the right-hand side to be implemented and plugged into our server. Now, the first one being the character query. The second being the character starships resolver, and the third one being the type character type resolvers, right? To be runtime safe, they must be, following all the TypeScript types and returned correctly. Cool. So in summary, when is it safe? For our team, that means when all the missing resolvers are implemented, like the example of starships, and it's when all the resolvers return compatible types, like the character type resolver. And for my team specifically, we want the code to not compile until all of the issues above are resolved. So that was runtime errors caught early. Next up is speed of development prioritized. And what that means is, it's very straightforward. Like, we want things to be quick. It must be quick to get started, meaning simple setup, less dependencies. We also want all the boilerplate things to be managed, right? We want to get straight to the business logic, right business logic, things like wiring resolvers back to some arbitrary resolver map, and that's what I call admin stuff, and we don't want to be bothered with that. By we, I mean the engineers in the team. We want a consistent convention that's enforceable, that makes everyone follow, and so that when everyone follows the same convention, then it's easy to write tooling to catch errors, and everyone understand where to find the business logic. And last but not least, we want good performance out of our workflows. For example, if I make a change in my server, like the running dev server must be reflected immediately, and so I can test manually or run any unit tests. Cool. So that's the requirements that we set for ourselves, right? Now let's start planning for the solution. The first thing is for type safety. So I wasn't part of the GraphQL Code Gen team at the time, but I knew of it. I was using TypeScript Resolvers plugin for my personal project written in TypeScript and Node. So I'm kind of familiar with the types it generates. So for me, that was a natural pick for type safety. For runtime safety, though, it's a bit more tricky. It's not kind of built into GraphQL Code Gen. But there's a concept of mapper in Code Gen. So on the left-hand side here is a character mapper. That's the kind of interface that we can declare and wire it into the Code Gen setup so that it forces our character query to return this interface and all the subsequent resolver to be able to consume this type, kind of like the type hints that we were getting at the start of the session. And on the right-hand side here, we got what generated from the resolver plugin. And for this, we get the character resolvers type, which declares that we can get the ID resolver. We can implement ID resolver or name resolver. So for these, in our example, we know we don't have to implement them. But for Starship, we know we have to implement them because they are not in the character mapper, right? We have to implement them. And this is important later on when we talk about runtime safety. And next one is for type, right? We know we have to implement this because of the type mismatch, right? So it's almost like we need something to be able to read TypeScript, like programmatically. sorry, I'm not sure what happened with the slides, but I was saying we need something to be able to read TypeScript programmatically, and to compare these two types, to find the missing resolvers, to find the compatible return types. And if any of them are missing, we want to inject this resolver mapper into the skeleton into our resolver map, right? And for a really long time, the answer is like right in front of me. I felt I could feel it, but the answer is like right behind me right now, and that's TypeScript. More specifically, it's the TypeScript compiler. Right, this is the missing piece that we need in our solution to make sure we achieve the runtime safety. Cool. So the big idea here is we're already running GraphQL Code Gen to read and generate types. What if we hook into the TypeScript compiler as part of this process and statically analyze all the types to find what we need to implement, and then inject them into our existing code and to make sure our engineers implement them, right? So that was the idea at the time. Now, for speed of development, what we want is all of our boilerplate implemented. And we already have a tool that's really good at generating types, and it is GraphQL Code Gen. So we want all the types and files to be generated for us if it's not business logic, right? And then we also want to make it fast. Like whatever process we put together here needs to be fast. Cool. So this is planning the solution. What about the building process? So building process, we just cannot jump into building this. What if there's a lot of questions in our mind, like does it, first of all, solve my immediate problem, right? Like I need to review my own patterns and the team's patterns to see that what we're gonna build would solve it. And if it does, I also wanna go out to the wider team, near me at SIG, right? Are they facing the similar issues? Are they seeing runtime issues? And how would they solve it? Maybe they already have a solution. So, understanding those solutions and comparing the solutions, right? And then the next step is going even wider to the GraphQL community. And shout out to the GraphQL Discord server. So it's a great place for to get connected, to understand what's already in the community, and get feedback. So if you haven't joined, there's a channel for everything. You can find me in the channel for GraphQL Code Gen. Ping me anytime. Don't be shy. I'm always happy to chat. And then, last but not least, I needed to learn new skills to be able to build this solution, right? The first one being writing code gen preset, and that is to generate a lot of files really quickly. Another important skill was to use TypeScript compiler API effectively, right? And also how to use TypeScript compiler API without crying myself to sleep. So it was a really big challenge at the time, but super fun by the time of it, by the end of it. So I looked at it like this at the start, but you can look at me now. It was fun. So that's the building process. We iterate on this a few times, and shortly after. That's a very weird way to say shortly after, but shortly after we got our solution, and our solution is what we call server preset at the CodeGen team. And I'm going to go through how to set it up and exactly what it does next. So the setup is very simple. You install two packages, the first one being GraphQL Code Gen, And second one is the server preset. And this is currently published under my namespace so that I can iterate a lot quicker and, because I'm more familiar with the setup and all that. So currently under my namespace, but supported by the team. Cool. And if you already used GraphQL Code Gen, you'll be familiar with something like this. This is a Code Gen config. And to use server preset with this, it's fairly straightforward. You just import this define config. It's already fully typed, so it's easy to set up. And then you call it a few lines below too. And that's all you need to do. But actually, currently on the screen right now is the resolver generation that says minimal. So this is a config option that I recommend for teams who have used the server preset before. So the team knows the convention and where to put all the file on the file system and so on. So if you're already familiar, then try this because it will generate less boilerplate. But if you're not already familiar, then try without this and kind of understand how all the files are generated, are wired up together, and work together. Cool. So let's talk about development flow, right? Fairly straightforward. You only need 2 files to get started. And you can see that source/schema is the folder that we point our server preset to in the previous slide. On the left-hand side is a schema. That's straightforward. On the right-hand side, though, this is the convention of server preset. What it says is next to this schema.graphql file, we create a file with a .mapper segment. And what it will do is it will statically analyze this character mapper, right? It sees the word mapper, and it understands that this mapper is specifically for the character type on the left. So you don't have to go into your code gen, you don't have to manually wire them up. If these 2 files are next to each other, the convention would wire up for us. So 2 files, and then we will run code gen. When we run code gen though, our resolvers, as we talked from the before, will be generated for us, and it will ask us to implement these resolvers. Otherwise, there will be runtime errors. So it's our way of enforcing our rule from before. Now, all the root level types, resolvers must be implemented. That means all the query, all the mutation, all the subscription, right? So that when people try to use it, we don't run into errors. Now, I also say server preset will enforce this. That means when someone tries to delete this skeleton and run code gen again, this will be analyzed, and it will say that you need this file, and we'll inject it into the code again. So no one can push this code to production without implementing the business logic for it. Similarly, we got the character resolver map. And in this case, it also tells us why this resolver map is generated. And it injects starships and type resolvers into this file for us. And very similarly, if you try to delete these 2 resolvers, run code gen again, they will be injected into that code again. So it will be handheld. So it's almost like you have me, sitting next to you and say you need to implement these 2 resolvers when you use this code gen. Cool. So in summary, this is the kind of workflow that we're talking about here. So first of all, if you want to add something, you update the schema, right? Should be already be part of the workflow in my team. And then we update any mappers if required, so it can generate resolvers based on that. Run the code gen command, and then we go straight to writing business logic on the skeleton it has generated for us. And talk about wiring up to the server. This is, should only be done once, so it's a one-time cost. And when we generate code gen, it will generate the type defs and the resolver map for us. Right, so this file you don't even need to touch. And on the screen, I'm using GraphQL Yoga, which is another tool by the Guild, but you can use it for Apollo server. Just wire it up the same way that you would other resolvers. And then I want to also take a look at this resolvers map. Right? It's generated. It looks for file in our file system, things that automatically generated or things that you would create and then wired up to this automatically. So in summary, ideal workflow, right? Like, did we get type safe by default? We got it by integrating CodeGen and server preset. Did we get runtime errors caught early? We've got it by using the TypeScript compiler as part of CodeGen process, and speed of development. Engineers are able to just go in and fill the skeleton resolvers and get really quickly develop and push feature to production with confidence as well, because they cannot push broken code, missing resolvers, for example. Right? So at this point, everyone's happy. Like, that's me. Yeah. More importantly, my marriage is safe. My wife no longer sad. And with that, I want to have a quick chat about like the community and the GraphQL Code Gen. We've been around for almost as long as like GraphQL, probably like 10 years, but who's counting? And like we feel like we deserve a happy birthday hat. And this is where I'm asking everyone in the room to like sing happy birthday to GraphQL. No, I'm just kidding. You should see your faces. Cool. And why I want to bring this up is at the start of our journey, we were generating client-side and server-side, and we focus on type correctness, right, for the community to use. Now, we also released a major version literally yesterday that supports federation and resolver types much better, like removing a lot of bloats and things we are just wrong, right? So it's a very exciting major release. So check it out. Next up is it evolved, right? As the community evolved, CodeGen also evolved to act as a compiler. So in that example, we integrate with TypeScript compiler into our code and analyze statically and do things with our code automatically, right? And I need to give a shout out to GraphQL Gen, which is a library for Golang, that does very similar thing. I used to work at 99 Designs with the team creating GraphQL Gen, so lots of inspiration from there. And last but not least, there's a new use case for being code modder. So Apollo Client v4 comes out, and what that means is legacy generated hooks plugin, a community plugin that CodeGen team has been maintaining, no longer works well with Apollo Client v4. And knowing this, we created a code mod that hooked into CodeGen to help with the migration of that into our client preset, right? What I would want to iterate here is every day there's a new use cases that's coming up by the community, right? Driven by the community, and we learn from other libraries as well. So, like, really appreciative of the community support, and which drive the direction of both GraphQL and GraphQL Code Gen. So, yeah, I think that's enough of me confessing my love to all of you in the community. So, which leads me to summary. We talked about the ideal server workflow, right? We talked about how to plan, build, and integrate this solution into existing team. And this is integrated into my teams at SIG and also at Hive, which is an open source project by the Guild at the same time. And we look at how it works and how it helped the team ship code faster with confidence. And with that, I want to say thank you, everyone, for listening. I'm Eddy from the Guild, and you are awesome for being here. Yeah, come find the Guild at our booth. We love to chat about anything and everything. So